Hello students, welcome back. In this video, we're going to introduce the core mechanic of our game, light zones. In Glowfield, the only place a player will be safe from the darkness is when they are inside one of our light zones. Our light zones will be rings of light that fill our arena, and as time goes on, these light zones will shrink and shrink and shrink and fade until they go out. Once they go out and we enter the darkness, we'll eventually begin taking damage. So this is going to set up a nice system of urgency and gameplay for us with our light zone system. So let's head over to our computer screen and dive right in. So right now I have vscode.dev open and I've got my lesson 3 starter file here for light zones. I'm going to minimize this browser tab here, and I'm going to open that file directly so I can also see it in real time. So let's see what we got here when we run our game. So here's our start overlay. I'll hit enter, and it just looks like it's exactly what we had before, right? I can do a game over hotkey. I can maybe restart the game with the R hotkey. Zero light zones at all. There's no light here. So we have to create the light. And let's head over to our code and get working on the light. So lesson number 3, our core mechanic of light zones. Mission number 1, it says we want to add our light zone constants. So we're going to have some constant variables for this new system. Our constant variables, I don't even have to do Control F to bring up my search bar. I know where my constants go. They go right inside of the student edit zone, because these are the things, these are the variables that we can tweak and adjust, and they will change how our game looks, how our game plays, and how our game feels. And every time we introduce a brand new system into our game, we'll most likely put some of these variables or parameters that we can tune right here. So we have 2 variables, 2 parameters that we can finely tune to adjust our light system. We've got something called center light radius and light shrink rate. So we had said that our light is going to be a circular sort of ring of light, and we're going to start with one centered right here in the game battlefield, so that when we start, our player is inside of one. So we just got to define what the radius of that circle is going to be. So right now it's set to 0, which is really bad because that would be no light at all. I'm going to set it to 220. I like that value. So as we go through and build this lesson out, you can adjust this to make your starting light zone larger or smaller. But that light zone is not going to stay at this radius for the entirety of our game. It is going to shrink. And so we have to set the shrink rate of our light. And so right now we're just going to set it to one constant rate. So whatever we set it to, it's going to be that for the entirety of our game. But eventually we'll find a way to make our game more and more difficult the longer we play the game. And one of the things we can do is we can make the lights shrink faster and faster and faster and faster the more we play it. But for right now, we will just use a constant, and I'm going to set it to 0.21. And so this is going to be pixels every single frame. Later, we'll turn that into a time-based system. But for right now, we're running with frames. All right, mission number 1 is done. Of course, just defining this data, we're going to see 0 changes here. This is still just our game from our last lesson. No light zones in place yet. So let's search now for mission 2 and let's see where it takes us. All right, mission 2 is all about generating the light data. It says create a data structure for the light zone object. Store X, Y, radius, and starting radius properties. All right, so before we get into this, let's just see we're in this function called generate light data. Let's see where this is in location. So, all right, I've got update player, get input direction. We've seen those. And then next I have a sequence of functions about this new system. So I need to generate my light data. Then I have a spawn light function and an update lights function. And typically, anytime I introduce a new system into a game, I try to have these 3 functions. I'm going to generate the data for that specific system, and then I will spawn an instance of that system. I'll spawn a light. And you can imagine, I'm going to hopefully have like lots of light sources. I'll have a ring of light here and a ring of light over here and a ring of light over here. And I'm going to have to move from one light ring to another to stay alive. And then lastly, we're going to update that light system. We'll update the data. So anytime we introduce a new system, whether it's our lights or maybe we'll have like collectibles or enemies, we will generate that data, we'll spawn that data, and we'll update that data. So right now we are looking at generating our light data. And if you look here, this function, it takes in 3 pieces of information. These are called parameters. So we have to give it an X coordinate, a Y coordinate, and a radius. Remember, our light zones are going to be circles that exist somewhere in our game arena. So the X and Y values are going to be the center of the circle, and the radius is how big we want that circle to be. So we can position our light rings exactly where we want them. So when we call this function, we will say where the center is in the X and in the Y. And we'll also say what the radius is. So we're going to return an object that has 4 properties: X, Y, radius, and starting radius. So where are we going to get our X value from? Well, I could hard code it as we're always going to place it at an X coordinate of 100 and a Y coordinate of 500. We could do that, but then every single light zone that we create will be stacked on top of each other, and we absolutely don't want that. We want these to always change, which is why we are taking in 2 pieces of information, 2 parameters, an X and Y value. So the X property of my light that I'm creating is going to be that X value that I passed in. The Y property of my light will be that Y value that I passed in. And guess what? The radius of this light ring, this light zone, is going to be the radius property that I brought in. Radius. And then we're also keeping track of the starting radius as well. Well, I guess the starting radius is going to be radius 2. And the reason why we're doing both of these things is our starting radius will never change. So it's always going to be, I don't know, let's just say it's like always going to be 100. But our radius will change. And so maybe when it first is created, it will be 100. But then after, a handful of frames that have elapsed, maybe it's going to be 95. And then a bunch more frames elapse, and now it's 80. And then it's 50. And then it's 29. And then it's 10. And then it hits 0. And that's when our light goes out. So we got to keep track of both of these values. All right, mission number 2. I think it's done. I think it's in the books. We have generated our light data. Pretty cool. So we defined some constants for our system, and now we are generating the data for our object. And it's an object because here we have it inside of our curly brackets. We're not doing anything with that object though yet, so nothing is happening. So I think we got to go to mission number 3 next. Let's keep building out this system. We want to spawn the starting central light zone. Okay, look at that words. We got to spawn it. Didn't we just see a spawn light function? Where was it? If I zoom down, we had generate light data, and then we had spawn light. Look at that. So this function, spawn light, I think this is what we got to call. But the question is, where are we going to call it? And look, it takes in 3 pieces of information: an X value, a Y value, and a radius. And those are going to become the X and Y value of our center of our circle and the radius of our circle. So let's go see where mission 3 is going to put us. It puts us right in the reset game to default function. So when we reset our game, we want to make sure that we create our center light radius. So as soon as we start the game, bloop, we have a big protective light ring right here for us. Now, here's the main thing though. We're going to create lots of light rings, right? As the game goes on, we're going to spawn light zones all over the place. We need a place for these light zones to live. So if I scroll up just a little bit, let's look at our gameplay variables. You can see we have a brand new gameplay variable right here called lights, and it's defined with 2 square brackets. That means this data type is something called an array, and an array is sort of like a container. It holds things. Whoa, that's not what I wanted to spell. Container. It holds things. So what does this array hold? Well, it's going to hold all of our light zones. So maybe I have light 1, light 2, light 3, and light 4. Maybe I got 4 lights in my game world. Imagine if I wanted to do an operation on every single light, and it required me to write, I don't know, like 4 lines of code. Well, I could write 4 lines of code for this light, and then another 4 lines for this light, and another 4 lines for this light, and another 4 lines for this light, which would make 16 lines of code. But what the array allows us to do is, instead of writing 4 lines of code for each and every light in this container, I write 4 lines of code for the entire container. And then I just apply those lines to every single object that is in our array. And this is something that we're going to see probably in this video and most certainly coming up. So we have this container where we can put all of our lights. So let's go back to mission 3. Now that we know that that's there, when we reset our game to defaults, the first thing we should do is we should take that container and we should empty it out. We got to make sure that if there were any lights that were created, maybe from the previous game that we were playing, imagine I had like 5 lights here. If I die, I don't want to start my next game with 5 lights. So when we reset our game to defaults, we got to empty it. So there we go. Boom. We've emptied that array. And now what I want to do is I want to create 1 light. And so I'm going to use that function that we just looked at called spawn light. And so spawn light, look, it tells me right here, what does it need? It needs an X, a Y, and a radius. So I want this to be in the center of our arena. So I got to specify the X value here. Well, we have the width of our canvas, and if I divide it by 2, bloop, that's going to put me right here. So my X value that I'm going to pass in is going to be width divided by 2. I got to pass in a Y value. You could say, oh, let's just use height divided by 2. But height divided by 2 is going to center me in the whole canvas. It's going to put me like right up here. But I want to center the light zone in the playable area. So we gotta add in this HUD height to shift it down. And I think we did that exact same thing when we looked at look at when we positioned our player, we did the exact same thing. So we're going to do the exact same thing here. Instead of height divided by 2, we're going to do HUD height plus height divided by 2. And now I need a radius. Well, the radius that I'm going to use, I think we had a constant. Yeah, right here. Look, it's right here. I'm going to tab to autocomplete. It's our center light radius. So I'm going to pass that information into the spawn light function. Let's just go look at that spawn light function. Make sure we fully understand what's happening. So this function takes in those 3 pieces of information, and then what's it doing? It's taking that array, that container that we talked about, that we had just emptied out called lights, and it's calling push on it. What push does is it puts something into that container right at the end. So imagine if my container already had like light 1 and light 2, and then I pushed a new light into it, it would go right here at the end. Now, how are we getting that light? Well, we're getting that light from the generate light data function that we were working with in mission 2. See, this function returns something to us. It returns that light object. So that light object that I have highlighted right here is returned and takes the place of that code right there. It gets pushed into our array of lights, and now we have it to work with. All right, so I better get rid of that before we crash the program with some rogue code. I think mission 3 is done. Let's just make sure I double check. All right, so we emptied the light array. We spawned a brand new light. Nothing. Boy, I really want my lights. I want to see them. Well, if you think about it, we are defining the data, but we haven't yet drawn the data, right? We define data. We're saying, hey, let's create this object. So now we have a light object that exists. It's just that we're not drawing it. So let's look and see at what mission 4 is going to have us do. And would you look at that? Mission 4 is all about drawing our light objects. So we got to render this object to the screen. Whoa, it looks like in this function of draw lights, there's quite a few missions that we're going to do later on. But right now, let's just focus on mission 4. We've got this draw lights function, which if I look at my draw scene function, remember, draw scene is getting called. Let's just backtrack to make sure we understand this. I've got a function called setup, which is brought in by our P5 library that we imported. That runs once every time we restart our game. And then I have the draw function, which runs every single frame of the game. Every single frame, we're going to check. If we're in play mode, we update the player and update the lights. And no matter what, we call draw scene. So all of these things are going to happen every single frame. Our background gets drawn. Our lights get drawn. Our player gets drawn. Our HUD gets drawn. And if certain conditions are met, our overlays get drawn. So we are focused now on our lights. So right now it says draw the light zones in the scene. Render the circular light area on the map. So it looks like I've already got a paint in my paint bucket. I've got light fill color. I just need to draw a shape. And so we want our light zones to be a circle. So let's call the circle function. And the circle function needs 3 pieces of information. It needs an X value and a Y value for the center. I don't know. Let's do like 100 and 300, I guess. And then it needs a radius. I don't know. What do we want the radius to be? 50? We could just guess these numbers, but now I'm actually rendering something to the screen. Hey, it's a light zone. It's terrible. I mean, it's not in the center of the screen, which is where I wanted it, and I do not think it's the right size. Didn't I say I wanted the radius to be like 220 pixels? So this is bad. So where are we going to get this information from? Well, we're going to get it from our light object. So if we look here, we are looping through our array of lights. And so this is where that array, that container becomes so powerful, because imagine if I had light 1, light 2, light 3, and light 4. This line right here, this for loop, allows us to move through and access each and every light of the array lights. So the first time we run our code, this variable right here, light, which is very vague, right? It doesn't tell me what light, it's just light, is going to be light number 1. And then the second time, it will be light number 2. And then the third time, it'll be light number 3. And the fourth time, it will be light number 4. And then it will stop because there's no more lights to work with. So right now, I only have 1 light in my array. Remember, we spawned it. So right now, it will be that 1 light. But what I'm going to do is take that light and I'm going to access its X property. I'm going to take that light and access its Y property. I'm going to take that light and access its radius. But if you remember, the circle requires a diameter. So I'm going to take that radius and I will double it. I think now if we run this, oh, that is a beautiful light zone. Look at that. And here's the wonderful thing. We could spawn more light zones. Let's just have some fun here. I'm going to go back to mission 3 where we spawned our starting light zone. Let's just spawn another light. Let's see if we can create 2 of them. So I'll spawn one at 100, 300, and a radius of 100. And then I'll spawn another one, spawn light at, oh, I don't know, 400 and 250 with a radius of 200. Let's just see if we now see 3 light zones getting drawn, because we have them in an array and we're using something called a for loop to write all of our code for each object in that array. Let's check it out. And would you look at that? I got 1, 2, 3. We even got this nice overlap going on. So this is working wonderfully. Let's get rid of those 2 lights because we only want to start with 1 central light. Very good, very good. So where's mission 5 going to take us? So now we have our light, we're drawing it, but it's not getting updated. Remember, there's 3 levels to this game development. We have to define data, update data, and draw data. We've defined it. We've drawn it. Now we need to update the data so that this light zone that we see here begins to shrink and get smaller and smaller and smaller. That's the core mechanic. The core mechanic is not big yellow circles that exist in our game. Our core mechanic is big yellow circles that shrink with time. So let's look at what's happening in the update lights function. We already know, I think we've looked at it, this video, that this function is getting called every single frame of our game. Because if I go back to my built-in P5 functions, setup and draw, inside of draw, which runs every frame, if the game is in play mode, we're updating the player and we are updating the lights. So this function is getting called every single frame. And let's look at what's happening. We've got another for loop. Hey, that means we want to do these operations on every single light that is in our array. But this time, it definitely looks a little different. It doesn't say, you know, for const light of lights. It's way more complicated. For let I equal lights dot length minus 1 I greater than equal to 0, I minus minus. What in the world? Well, when we loop this way, we are doing it for one specific reason. Anytime we want to remove an element from an array, right? We want to eventually get rid of something. This is the way that we are going to do it. And let's talk about why here for a second. So here's our array. I got light 1, light 2, light 3, and light 4. These objects in an array are at specific positions in the array. Those are known as their indexes or indices. This first element, believe it or not, is at index 0. This next element is at index 1. This next element is at index 2. And this next element is at index 3. Our array or container has a length to it. We just count the number of things that are in it. 1, 2, 3, 4. So we have 4 elements in that array, but we're defining this variable I as the length 4 minus 1, which is 3. That number right there gives us the last position in our array. And this allows us to loop through our array going from the end backwards. And that is extremely special when you want to remove something from an array. If you started here at the beginning and looped forward and removed something, you could get some wacky behavior. So anytime we want to remove something, we're going to loop backwards using this method right here. So I will start, it'll be 3, and will allow us to access the object that is at the 3rd position, and then I will be 2, and we can access the object at the 2nd position, then 1, and then 0, and then it stops. All right, so with that out of the way, let's look at what we're doing. It says, mission 5, we're going to shrink the light. Shrink the light radius with every frame. Use the correct value to decrease the light radius. So if you look right here, we're taking our array, lights, and then I got square brackets with that variable I. What that means is open up your array, reach into the container, right? So lights, let me see, maybe I can just do Control Z. There we go. So reach into the container and grab the light that is at this position. So when I is 3, we're going to reach into the container and grab the light that is at position 3. Right here, and we're going to target its radius property. The next time through the loop, we're going to reach in and grab the light that is at container position 2. So we'll reach in and grab this light, and so on and so on. And so if we look right now, we're updating the radius by subtracting 0. I don't think that's going to shrink the light at all. I don't know. Let's just put a number in. Let's subtract 50. Is that good? 50. Let's see what happens. Will our light shrink? Whoa. I don't know what just happened, but it was not the expected behavior. Our light shrinks and then it blows up. So that's not what we want. So 50 is not good. What if I don't know, can I make it 1? Okay, so that sort of works. Oh, and then it keeps going. It's not what I want either. That's funny. That's really funny. So this is not working. In fact, we have, what value do we want to shrink it by? I think we have a constant. Don't we have a constant that we set? Yeah, look at this. We set this constant for our light system. It's called light shrink rate. So I had it highlighted and then I hit tab for autocomplete. We set it to 0.21 because we're working in pixels per frame right now. So this is pretty nice. Now we should have a much more controlled shrink. Yeah, and that looks a lot better. We're talking about something fading out, right? Not just like being blown out or going out quickly. It's fading out. Now, I don't notice that it's fading at all. It's still pretty bright, but it's getting there. It's getting smaller and smaller and smaller, so that's nice. But this is weird. I don't like that. See, it's getting smaller, and then it gets bigger and bigger and bigger and bigger. What in the world? Well, the reason is, let's look at mission 6. Once the light's radius hits 0, we actually have to remove the light object from the array. We're still shrinking its radius. It's going in the negative direction. So and I think what's happening there is it's just moving it, instead of being to the right, it's moving it to the left, which is just some odd behavior. But we're not actually removing the element from the array. And we said, when we want to remove things from our array, get things out of our container, this is the way we're going to loop through it. So here is why we do that. We're going to ask a question. It says, if false. Well, guys, false is always going to answer false. The answer to this question is always no. But we want a question here that sometimes is yes. And if the answer to this question is yes, we are going to remove that light from the array. And this is how you do it. You type the name of the array, lights, and you call splice. So remember, we used push to put something in the array, and we're going to use splice to take something out of the array. You just have to tell the splice method what position in the array do you want to reach in and remove the element at. And we're going to use that variable I. And then you have to tell it, starting at that position, how many elements do you want to remove? We only want to remove one. So what question will we ask here that when it evaluates to yes, it will be time to remove that particular light from the array? Well, we're going to target the light's radius. So I'm going to use my array lights. I'm going to reach in and grab the light that is at our current position, and I'm going to target its radius, just like we did here. But instead of subtracting a value, I'm going to check to see if that radius is less than or equal to 0. If it is less than or equal to 0, it is time to remove it from the array, and we will do that right here. Now, when we run this, let's check. Our light will shrink, shrink, shrink. It should shrink right down, and hopefully, once it hits 0, it's going to be gone. So it's not going to continue to grow and then do this weird behavior because we have just taken it out of the array. Let's see. Look at that. And now we are in total darkness. We are almost set with this really great core mechanic of shrinking light zones. But the whole idea was that this light zone should fade as it shrinks. And right now there is 0 fading. So mission 7 and 8 is going to put us in our draw lights function again, because we are going to work on the fading of the light. So mission 7 is all about figuring out the transparency of the light. We're going to reduce transparency as the radius decreases. So we've talked a little bit about transparency. So if I come back up here, let's just see. Yeah. See, like we've got like our HUD background color is sort of transparent. We use an RGB alpha string. And this last number right here, the alpha channel, is the transparency. So colors are crazy. So we can define colors as hexadecimal strings, as RGB alpha, we can, or just RGB, we can define them alpha, or the transparency, in a variety of ways as well. And so we can use a value of 0 to 1. So let's go back down to our mission. So we could use 0 to 1. I'll put some notes in here. So transparency could be 0 to 1, or it could be 0 to 255. 255 meaning, you know, like the 1, like it's not transparent at all. 0 meaning it is fully transparent. So it depends on how we define the color and the system that we're using. In this case, we're going to define an alpha going from 0 to 255. So if right now it's just set to 255. That's the maximum value, but we somehow want to dynamically change it so that it will get smaller and smaller and smaller and smaller. So like if I multiplied this by, 0.5, it would get smaller. And if I multiplied it by 0.25, it would get even smaller. And if I multiplied it by 0.10, it would get even smaller. Those decimals are nothing but a fraction, okay? So like 0.5 could be like 10 divided by 20. There you go. We just made the transparency different. And, 0.25 could be 5 divided by 20. But I don't want to put actual numbers in here. I want to put values that will lower as the light shrinks. And so as the light shrinks, we are going to target the light's radius. So I'll do light.radius. I'm using light here because if I scroll up, we're in that for loop again. So this for loop, we're not removing anything from the for loop when we're drawing, so we can just loop directly over our array for const light of lights. So I'm going to target this light's radius, whatever its value is, and I'm going to divide by light.starting radius. Remember we had said it's starting radius. So in the beginning, these things are equal. So it's like 20 divided by 20, which is 1, and 1 times 255 is 255. So we get our maximum value here. Our light will not be transparent at all. You won't be able to see through it. And as our radius gets smaller and smaller and smaller, this fraction will get smaller and smaller, and our alpha will be decreasing to 0. So that's mission 7. We've defined that alpha, but now we actually have to use it. So we're going to look to mission number 8. We're going to fade the light as its radius shrinks, and we're going to use that calculated transparency value. So the first thing that I'm going to do is we're going to say, all right, In mission 4, we filled our paint bucket with light fill color, right? So that color is always the same. It's set here with no alpha channel. I'm going to comment that out because we're not going to use it. A comment can just be 2 slashes. We're not going to use that anymore. Instead, we are going to calculate our color every single time we call draw lights. So let's create a const here, and I'll call it draw color. So that's going to be the color we're going to draw with. And we're going to use this color right here, which didn't have a transparency, right? If I look, there was no alpha channel here. Nope, no alpha channel at all. We are going to turn it into something called a color object by calling the color function. And I'm going to pass in light fill color. Now that I have this color object here in the variable draw color, I get access to a bunch of really cool methods used for colors, or like functions that we can use with colors. So I'm going to say draw color dot, and then I'm going to use set alpha because I want to set the alpha channel of that color. And color objects need their alpha channel defined from 0 to 255. Hey, we've got that right here. It is our alpha variable that we set in mission number 4. Now that I have my color set with its alpha channel, I'm going to put that paint in my paint bucket. So I'll fill with draw color. All right, so now when we come down here and we draw our circle, every time we draw our circle, we're going to use a brand new paint in our paint bucket that has a different transparency or alpha value based on how big the radius of our light source is. Ooh, I think this is going to work. Let's run this and see if we get our fading light. Is our core mechanic fully implemented? So there is our light source. And it looks like, oh yeah, it looks like it's fading. It's getting darker and darker. I'm getting scared. I got to stay in the light. I got to stay in the light. And once that radius goes to 0, the light source fades out completely. All right. I think this is a wonderful place to stop. Great job building out the core mechanic of our game. We now have this central light zone, which is going to be like our safe area where we cannot take damage, where we probably heal from damage that we've taken someplace else. And it just shrinks and shrinks and fades in time until it goes out. This is a wonderful place to stop, and we'll build on this mechanic in our next video by adding probably a resource system that we have to manage in the way of like health. So then we'll be able to take damage and heal damage based on whether or not we are in our light zone. So we'll do that in our next video. I'll see you then.